Hello? Hello?
Yes, sir.
Am I audible? ଶୁଭା ହଉଛି?
ଆଜ୍ଞା ସାର୍।
ହଁ ଠିକ ଅଛି। ଦେଖାଉ ସ୍ଲାଇଡ୍ ଦେଖାଉ
ଆଜ୍ଞା ସାର୍। ଆଜ୍ଞା ସାର୍।
ଟିକେ ଦେଖିଲ।
ୟେସ୍ ସାର୍ ଦେଖାଉଛି।
ହଉ ଠିକ ଅଛି।
ଆଜ୍ଞା ସାର୍ ଦେଖାଉଛି।
ହଁ ହାଇଡ୍ରୋଜେନ ଆଟମ ର କ୍ୱାଣ୍ଟମ ଏକ୍ସପ୍ରେସନ ପଢୁଥିଲେ। ଆମେ ଯୋଉ ହାଇଡ୍ରୋଜେନ ସ୍ପେକ୍ଟ୍ରା ଲାଇନ ସ୍ପେକ୍ଟ୍ରା କଣ ପଢୁଥିଲେ ତାର କ୍ଲାସିକାଲ ମଡେଲ ଟା ପଢିବା। ତ ନିଲ୍ସ ବୋର୍ସ atomic model explain the Bohr's atomic model. Bohr's built upon a Planck's and Einstein's idea about quantization. The hydrogen atom has only specific allowable energy levels, which is quantum. The atom doesn't radiate energy while within energy. So atom ta energy radiate kariben when it is in its energy level. ଯେତେବେଳେ ଗୋଟେ energy level change ହେବ ଧର lower state को higher state को ଯିବ or higher state को lower energy की ଯିବ then it can radiate or absorb energy. When electron transition takes place, means it to different energy levels only by absorbing or emitting a photon whose energy equals to difference in energy. तो गोटे लोअर स्टेट को हायर स्टेट को गला तो लोअर ରୁ हायर गले absorb energy higher ରୁ lower को गले it will emit the energy. So we'll give the h mu the energy difference will be energy of final minus energy of initial. So we'll get Hv. Limitation. It is failed to predict the spectrum for other atoms. So hydrogen Bohr's model of hydrogen spectra जो वाला, it failed to predict the spectrum of other atoms or hydrogen like atom like lithium, barium, beryllium, and helium like doesn't take into account of radiation of nucleus atom. So electron do not read this. So line spectra कौन मिलिला? Bohr's model was an attempt to explain how light was emitted when an element has vaporized and thermally or electrically excited flame test. But a flame, a sodium flame or neon flame देला hydrogen spectrum generate हवा. Through the experimentation, it was discovered that each element has a unique line spectrum with specific wavelength that can be used to identify. Rydberg equation. So Rydberg equation of 1 by lambda is equal to R 1 by n1 square minus 1 by n. So this is the जेतल hydrogen spectra हुए line spectra from 1 n1 orbital to n2 जाए और n2 to n1 आए. So we'll get this equation. An empirical formula equation used to predict the position and wavelength of lines in a given series in a specific region, that is electromagnetic spectrum. 1 by lambda is equal to R bracket 1 by n1 square minus 1 by n2. R is the Rydberg constant. Okay, ଆମେ equation आगुरु पढ़िଥିଲେ hydrogen. So R ର value होची 2.179 into 10 to the power minus 8 joule, that is the Rydberg constant. The electron in the atom occupies a specific energy levels, and this level is quantized or quantization. That means we can calculate the photon. The electron in the atom, so H mean how faster 2H mean 3H mean like this. We can count that. The electron may undergo a transition from one energy level to another. Remember that energy of emitted photon. So ये जो energy टा केमती जानिबु EI minus E final and final initial minus final energy. RH 1 by n1 square minus 1 by n square. So H mi होची SC by lambda. तो SC कटी तळକୁ पळेଇ आइला 1 by lambda is equal to this equation can be determined the lambda of a hydrogen wavelength of a hydrogen spectrum transition, electronic transition. So energy states of a hydrogen atom. Energy state means one state to another state gale जो energy change. When an electron in its ground state absorb energy from a photon called absorption. ଯେତେବେଳେ ground state absorbs energy from a photon. Ground state ରୁ higher state କୁ ଗଲା ତାକୁ the absorption. When an electron is promoted to higher energy level, it is the excited state. तो ଗୋଟେ state ରୁ ଆଉ ଗୋଟେ higher state କୁ ଯିବ by absorbing energy and that state is known as excited state. The emission is when the electron in an excited state comes to or returns to lower energy level and that time we get emission ମାନେ higher excited state ରୁ lower state କୁ ଆସିବ by emitting energy. So there is a direct relation between emission and absorption. So E is equal to minus 2.18 into 10 to the minus 18 joule z square by n square. ये होची energy state of a nth orbit of Bohr's atom or के orbital. So here energy of atom E, charge of a nucleus Z. Nucleus means hydrogen atom 1, helium 2, boron 3 like that. N is energy level, nth energy level. Predict तो ये होची energy level difference one energy level to another. So the electron jumps from higher energy level down to a lower energy level by emitting energy. If Ni means initial energy level less than Nf, Nf টা বড় ଅଛି, energy capture. So ଏଠୁ ଏଉ ground state to excited state ହବ by absorbing. The electron jump from lower energy level to higher energy level. So more or less do the revise the Bohr's model here. So Bohr proposed a model that included the ideal that the electron in a hydrogen atom moves around the nucleus. And Bohr's model कौन कहले? The electron is revolving around the nucleus only in a subtle allowed circular order. So Bohr model कौन कहला? Electron is circulating around the nucleus in a certain path. That path is known as orbitals or the orbit. And further, Bohr concluded the following points. Hydrogen atom exists in only specific energy states given by the Rydberg energy. This one is equal to minus 2.1 into 10 to the power minus 8 joule z square by n square. N square n final minus n. So here is the energy z atomic nucleus. So hydrogen atom can absorb only certain amounts of energy, not other. So hydrogen with certain amount of energy. This energy is quantized. This energy is fixed always. When excited hydrogen atom lose energy, they lose only certain amount of energy emitted out. The difference of photons given up by hydrogen atom produces the color light. So you got a color line the greater the energy lost by the atom, the greater energy is the photon. So now the hydrogen atom treatment will be treated in terms of Schrodinger equation. So Schrodinger proposed the theory of quantum mechanics which suggested that electron or any other particle exhibiting wavelength property should be restricted by mathematical equation called wave. So thus the electron, the movement of electron, a study of electron in as a wave-like property. So that can be described in mathematical equation in terms of wave function, that is in Schrodinger's equation. Specifically, he developed a mathematical formula to describe the hydrogen atom of a wave. This equation, which involves differential calculation, gives the probability of finding an. So here psi is the wave function. Psi square gives probability of finding of an electron at some certain point in a three-dimensional space at any given instant, but offers no information about the path of electron followed. The region in space where there is a probability of finding an electron is known as the orbital काहाକୁ କହିବା where probability of finding electron is maximum. In the Schrodinger equation, the wave function is used to calculate probability of finding. Where if we get psi, so we get definitely we get psi square. Psi square means probability of finding electron. Okay. Then we know from quantum mechanics that H psi is equal to H psi. Here H is Hamiltonian operator. Psi is the wave function. E psi is the energy value, that is eigenvalue, and psi is the function. Schrodinger formulated the theory of wave mechanics, description of behavior of a tiny particle that make up a matter in terms of waves. His wave equation describes the behavior of electron in atoms. So S psi is equal to E psi. Psi is the wave function of atomic orbital. A mathematical description of a motion of electrons on a wave in terms of position and time. Psi is the wave function of atomic orbital, a mathematical description which describes the motion of electron, matter as well as wave orbitals. H is the Hamiltonian operator, is the energy of atom. So that can be described in this term. So d psi square by dx square plus d psi square by dy square, d square by dz square. So in x, y, z only plus 8 pi square am by s square. E ହଉଛି energy, kinetic energy minus potential energy psi. So this is the mathematical expression of Schrodinger equation in hydrogen atom. Psi square is the probability of finding. So please look at this equation. This is very very important. Hamiltonian operator would be act upon the hydrogen spectrum. Next, in quantum mechanics, the electrons occupy the electrons occupy the specific energy levels. ଆମେ ଜାଣିଛୁ ଗୋଟେ ଇଲେକ୍ଟ୍ରନଟା ଯେତେବେଳେ ଯାଉଛି according to Bohr's model, it has some energy. That orbital has a specified energy. But they also exist within a specific probability volumes called orbitals with a specific orientation in space. The electrons within each orbital has a distinct flux speed. N is the principal quantum number which describes the possible energy levels, and pictorially it describes the orbital size. N is equal to 1, 2, 3, where orbital with the value of 2 is larger than orbital with value of 8. En is equal to minus 2.18 into 10 to the power minus 8 joules 1 by L square. For electron in hydrogen. So listen, this is 1s orbital, this is 2s orbital. So here within this orbital we have some specified energy. So that energy is equal to minus 2.18 into 10 to the minus 8 joule 1 by N square. So this is the different energy level in a hydrogen atom. Or n is equal to 1, E1 is the value, this one. When n is equal to, we know z square by n square this term divided by n square 2 row square 4. So this term divided 4 will come this one. So it will be this. Again, z square by n square, z square z1 by 3 the square house 9. So this term by 9, this will come this one. So like this, we can calculate the energy levels, energy of different levels in hydrogen. Okay, we look at this formula comes. What is the formula? This one, En is equal to minus 2.18 into 10 to the power minus 8 1 by n square. N square n 1 2 3 like this, n square. Next, so quantum mechanics tells that L is the angular moment of quantum numbers. Describe the, so what describes L? We know N is the principal quantum number which describes the energy of different levels of orbit. L is the azimuthal quantum number or angular momentum quantum number which describes the shape of orbital. What will be the shape of a orbital? So, shape for L value 0 that is S orbital, L value 1 that is p orbital, L value 2 that is d orbital like this. So from 0 to n minus 1 of each n. Suppose n value 4. The L value will be 0 to n minus 1. That means 0, 1, 2, 3. So therefore n, L, 2n plus 1 something. L is equal to n minus 1 to 0. Orbital designation, S orbital, P orbital, D orbital, F. So these are S is equal to symmetrical shape, P is a dumbbell shape, D is a double doublet. A was a magnetic quantum number related to orientation of orbital in space relative to the other orbital within the space L quantum number. It can have value between L and L minus. Ms is equal to spin quantum number. So magnetic quantum number related to orientation of orbital in space related to other orbital. So m ର value କେମିତି ବାହାରିବ? ମୁଁ କାଲି କହିଥିଲି L ର value depends upon L, m ର value depends upon L. So m ର value କେମିତି L ଉପରେ depend କରିବ? M ର value varies from S minus L to plus L. Suppose L ର value 2 ହେଇଥିବ, m ର value କେତେ ହବ? minus 2 minus 1 0 plus 1 plus 2. Okay. So ଯେମିତି n ର value ଧର 2 ହେଲା, l ର value 0 1 2 ହବ, 0 1 ହବ, n minus 1. Suppose l ର value 1 ହେଲା, r କେତେ ହବ? minus 1 0 plus 1. So all the quantum numbers are depend with each other. Orientation orbital L, ms spin quantum number. An electron has either plus half or minus. This is spin quantum number, sometimes referred to as spin or cross spin. So these are the quantum number derived from quantum mechanics. So we have studied about the hydrogen. We'll look at this one. ଆମେ ହାଇଡ୍ରୋଜେନ ପଢିଥିଲେ, ତ ହାଇଡ୍ରୋଜେନ ର ବହୁତ ସାରା ଆଟମିକ ମଡେଲ ରୁ ଷ୍ଟାର୍ଟ ହେଲା। ତ ହାଇଡ୍ରୋଜେନ ର ଡିଫରେଣ୍ଟ ଏନର୍ଜି ଲେଭେଲ ଆମେ ଏଠୁ ଜାଣିଲେ। तो ये रिकैप कर दिया देखो टी स्लाइड Edward constant, Edward equation. So we calculate the energy level of different orbital here. A hydrogen atom energy stats, different energy stats. So when in which case it would emit, in which case it would absorb from one energy level to another energy level. This is your total Bohr atomic model. Keମିତି revise, revisited the Bohr's atomic model. So what is the energy of nth orbital? Then that will applied in Schrodinger equation. That is very important. Schrodinger proposed this theory for quantum mechanics, which suggested that an electron exhibiting wave-like character and that can be expressed in mathematical equation in the form of wave function. Specifically, we developed a mathematical formalization to describe the hydrogen atom as a wave equation gives probability of finding electron at some point in a three-dimensional space at any given instant, but offers no information. So psi square is the probability of finding electron, where psi square is nothing but orbital, where probability of finding electron is maximum. So that will be calculated by Schrödinger's equation. This is the operator, Hamiltonian operator, psi is equal to E psi. Hamiltonian operator is a eigenfunction that will be expressed in this equation. So from this Schrodinger equation, we will get different quantum numbers. N is the principal quantum number, which describes the energy of a orbit. Then azimuthal, so different energy levels. N1 rocket energy, N2 N3 N4. Then L is the angular quantum number or azimuthal quantum number, which describes the shape of a orbital. S orbital, p orbital, d orbital, f orbital. Then here MSP quantum number to describe the difference. Then we'll go to the another unit one. So is it visible to all? PDF ଦେଖାଅ ସବୁଠୁ?
Yes, sir.
So till now we have studied about quantum mechanical treatment of in Schrödinger's equation in କଣ one dimensional box, three dimensional box, and hydrogen atom. So we'll see different approximation methods on the basis of one dimensional Hermitian hydrogen and perturbation. So three different one variation method. As states above introduction. In the previous unit, we have learned about the angular momentum. Generally, A is the angular momentum. How angular momentum will be calculated by using rigid rotator. Meaning of significance in terms its meaning, significance, operators, and the above function for above wave function for angular in the current unit will take up a very important aspects of quantum mechanical framework, that is approximation method. Approximate value of the terms. We would have realized the course so far the quantum mechanical study of system, empty bhala, the confined box, hydrogen atom, like this. Hydrogen like atom, Hermitian oscillator, rigid rotator we contain. So involving many body as we erase over the delay, just introduction. So variation method as states above, the variation method is an approximation method in which we make different guesses at the form of correct way by using a correct wave function. For example, we determine the corresponding energy of system. So by using different variation method, by using coordinates, x coordinates, y coordinates, z coordinates, we will get the corresponding energy. Needless to say, trial function must be well-behaved function. So we choose a arbitrary well-behaved function to describe a system. The energy calculated from this function will be greater than equal to other two constants. Energy value. So the energy value will be the method based on theorem for creation theorem can E bar average energy will be integrated from minus infinity to plus infinity, and this will be in the form of this wave function. This is the product wave function psi t h mu psi t df. That will be integrated with psi ts. So this is a Hamiltonian. So here we will get the perfect energy value by using different types. So here psi is complete Hamiltonian operator for the system being studied. E0 the energy of lowest energy state. E0 होची lowest energy state for my Hermitian. Here psi t is the trial wave function, that is an approximation to the true function. So here psi t is the true wave function. We require that trial wave function must be normalized. So normalized हवा पाई psi t psi star into psi should be 1. So we require that trial wave function must be normalized over the space of the true wave function system. From a normalized trial wave function, the denominator left side. So this is the expression for mathematical expression for a term. So now this term is normalized, so the value becomes 1. So we'll get the equation here like this. So we should note here that expectation E bar in equation 9.1 is not true. Expectation energy but estimate corresponding to trial. So this is the correct form of energy. Uh, so we have expression will get the true expectation energy. In this heat and trial method, we keep trying different well-behaved trial function until we are sure that no aspirate lower energy. So this is the energy approximation method of energy. Then we'll go to another. So here we have given that formulate a trial variation function of particular box M defined. So one dimensional box रे ଦେଇଥିବ one dimensional box having length. Compare the true ground state energy. ଆମେ ground energy ବାହାର କରିଥିଲେ one dimensional କଣ? ଏ ମନେ ରଖିଥିବ ଯଦି 8 pi square h by 8 ml square by dm. तो ଆମେ ଏଇଠି h square by dm d square ଏ ହଉଛି Hamiltonian फाइनल इक्वेशन कौन था एचएम तथा वेरिएशन का देखिदबा we should recall from unit 3 that one dimensional box has infinite potential worth x0 to xl whereas the potential inside the box is 0 तो हम जानते हैं वन डायमेंशनल बॉक्स मन थव x ru 0 ମୁଁ ଟିକେ ଦେଖେଇ ଦଉଛି वन डायमेंशनल बॉक्स जस्ट a minute तो ଆମେ ଏଥିରେ ଦେଖିଥିଲେ वन डायमेंशनल एनर्जी कैलकुलेशन करଥିଲେ फाइनल एनर्जी this is term n square h square by 8 ml square. So this is the energy expression for one dimensional box, and that will be m. So x0 ru xn thala, whereas potential inside the box 0 thala. Outside the zero not there. For boundary condition is psi 0 at x0 at and at x is equal to n. So psi t will be x l minus x l 0 less than equal to x. When x टा 0 ru l ଭିତରେ ରହିବ. So here we recall the Hermitian operator. Operator कौन था? A minus h square by 2m d square by dx. So this is the Hamiltonian operator will operate upon this x value. So will operate energy value calculation approximation 0 to l x l minus x. So this is the operator will operate upon the a value of x. So we know this is 1. So this is normalized version. Let us solve the denominator first. So 0 to l x l minus x x l minus dx 0. So this is x square l minus x square dx. So simplifying with this equation, x square l square by any x square l square except 12. So आपको एमती derivation the multiply आपको कर दो multiply करो. So we'll get integration करो integration value will come this one. So we'll get x रा value l पकाओ 0 0 पकाले 0 है जो 0 to l l को 0 0 है सब 0 हो गला l रा value s cube l cube l square total l5 it is x5 means l5 minus l5 by 2. So total value was L5 by 5. So we make a numerator. Puri numerator operata bar kar do. So we'll get this one. So we'll get the value. So I have to have a specific ଗୋଟେ term calculate କରିବା ପାଇଁ. So we will get this is one example of the necessary information. Why we need approximation method in quantum chemistry. So briefly describe how the variation method is used to estimate the gram state energy of a system. Then we will discuss the proof of variation theorem. So listen, we know wave function is a commutative combination or cumulative equation. Means A0 a linear combination of wave function psi 2 equals to this psi 1 plus psi 2 plus psi 3. So that psi 1 will be A0 psi 0 A1 psi 1 A2 psi. So in this way the psi function can be calculated in combination. So here A0, A1, A2 are coefficient of different wave function. Similarly, we can write the complex conjugate triad wave function. Psi 2 square star A0 star A0 star A1. So these are the combination of different combinations. So is I0 this one H. So ଆମେ ସେ ଯେମିତି ପକେଇଥିଲେ ଏନର୍ଜିର ସେମିତି ଆମେ ଏଇ ସାଇଡ୍ ଟି ଏ ସାଇଡ୍ ଟି ଷ୍ଟାର ଏ ଡିଟେଲରେ ସବୁ ଷ୍ଟାର ହବ ମାନେ ଓ ଏବେ ଇ ଷ୍ଟାର ହଉଛି ବଣ୍ଡିଂ ଆଣ୍ଟି ବଣ୍ଡିଂ ହଉଛି so we'll start ତାପରେ ଆକୁ କଣ ଆମେ ଏମିତି ଏନର୍ଜିରେ ଆମେ ପକେଇଥିଲେ କଣ ସାଇ ଟି ଏଚ୍ ହାମିଲ୍ଟୋନିଆନ୍ ସାଇ ଷ୍ଟାର ଡିଆଇ ପୁଣି ତଳେ ସାଇ ଷ୍ଟାର ଇଣ୍ଟୁ ସାଇ ଟି ଡିଆଇ ତ ସେଇ ଆ ବଦଳରେ ସାଇ ଟି ଷ୍ଟାର ବଦଳରେ ଆମେ ଏଇଟା ପକେଇବା ହାମିଲ୍ଟୋନିଆନ୍ ତାପରେ ସାଇ ଟି ଯେମିତି ପକଉଥିଲେ ସେମିତି ଭେରିଏସନ୍ ମେଥଡରେ ପୁଣି so we'll get this equation after this. We'll get this equation. So this combination of expression can be explained. ବୁଝିଲେ ଦେଖୁଥା କେମିତି ହେଲା ଏଇ ଦିଟା ଏ ସାଇଡ୍ ଟୁ ଆମେ ଏ ଇକ୍ୱେସନ୍ କୋଉଠୁ ଆଇଲା ଆମେ ଏଇଠି ଇକ୍ୱେସନ୍ ପକେଇ ନଥିଲା ସାଇଡ୍ ଏଇଠି equation. So this equation 9.1 will apply in there. Side distance. So it equation, right? The equation contains the equation. Then we'll solve like this. So if it will normalize, so this is normalized wave function. So we'll get 1. If we will orthogonal, that will be 0. So psi m star psi m d square equal to 1. আমি জানিছি দুইটা psi এর multiplication will be 1. That is normalized wave function. If multiply will be 0, that is orthogonal wave function. So wave function form a orthogonal set. These are individual normalized and mutual orthogonal. We can write this one 1, this one 1, this one 0. Further, since all the wave function of the state are eigenfunction of the Hamiltonian, we can write Hm H star mi di, Hm star Hm psi di here. So ये समूह को हमें कौन हैमिल्टोनियन ऑपरेटर है ये तो ये हैमिल्टोनियन ऑपरेटर will be eigenvalue em बाहर कोई नहीं तो हमको ए फॉर्म को लगेगा पड़ेगा okay so the questions these are functions of set are two eigenfunction of the Hamiltonian we can write this one like this so on simplification we get the following expression okay so the expression is like this so again this value will be calculated a0 ଏଠୁ ଆସିବ ଏ ସବୁ କଣ ମଲ୍ଟିପ୍ଲାଏ ହେଇଯିବ a0 e0 a01 A1 to everything addition to it. So this is the combination of eigenfunctions. So similarly, A0 ଏଠି ଆଉ E ର value ନାହିଁ ଆମେ H Hamiltonian psi is equal to E psi H Hamiltonian ଦ୍ୱାରା E0 eigen value ପକା ହେଲା ଇଏ ହଉଛି coefficients A0 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 ଚାଲ so we'll get this one after solving the equation. So suppose A0 and A0 star would be equal. So we'll get A0 square E0, A1 square E1, A2 square E2. So here similarly we'll get this one. Total mathematical expression. So either A0 A1 समान है square A0. Square है we can rewrite the equation like this. ଆମେ କଣ କରିବା A0 ଆକୁ ସବୁ ବାହାରକୁ ଆଣିବା E0 ଟର୍ମକୁ ବାହାରି ଆଣିବା ଆଉ E1 କୁ ବାହାରିବା ଆଉ E2 କୁ ବାହାରିବା ତାକୁ କଣ A0 ସହିତ ଆକୁ ହରିବା A1 ସ୍କୋୟାର ସହିତ ଆକୁ ହରିବା ସେମିତି A2 ସହିତ so individual କରିଦେବା ଏଇ ସବୁ ଏଇ ଟର୍ମ ସହିତ ଏ ତଳ ଟର୍ମ ଏଇ ଟର୍ମ ସହିତ ଏ ତଳ ଟର୍ମ so we'll get a different all are combination of E0 plus U1. So this term will be one coefficient. So from this you can देखो 8 term सहित 8 term सहित in the अलग ଏବେ କଣ ହବ this term would be one coefficient. So this lets A0 square by A0 square A1 square A2 square चालू this term let it will be B0 होची and this term let it to be a B1 and this term is B2. So one equation is B0 plus B1 B2 plus B1 is equal to 1. So this equation will become like this equation B0 E0 B1 E1 B2 E2 etc. So what is B0? B0 is this term, this coefficient related to A0 will become. So we'll get this expression like this. So regular energy term come to a simplified form. So here this implies that expectation energy is nothing but a weighted average eigenvalues energy. So energy this is eigenvalues and this is coefficient. So combination of eigenvalues. So energy average energy is the combination of eigen. So in this way we can calculate the approximation means approximate value of energy. The different way. It is obviously expectation energy E would be more than the lowest energy term in the expression. However, if there is only one contributor, so you'll get this one. So how calculate E value, expectation E value, or a combination of reaction of variation? ये देखिए आएगा so ଆମେ psi t କୁ ଏତିକି ଲେଖିବା psi t star କୁ ଏତିକି so ଆର କଣ question ପଡିବ the expectation energy as determined by variation method cannot be less than the true ground state energy of system expected এটা energy ground state ଠାରୁ କମ okay greater cannot be less than the ground state. এটা E0 ଖାଲି ହଉଥିଲା এটা combination of so E ବଡ expected energy the expectation energy as determined the variation method cannot be less than the ground state energy explain so this long type will be like this. We'll start from this one like there we to start 9.2.1 तो ଆଉ ଟିକେ ଲଙ୍ଗ ଟାଇପଟା ଦେଖ ସାଇ ଟି ଲେଖିଦବ ଖାଲି ମାଥମେଟିକାଲ ଏକ୍ସପ୍ରେସନ ଏ2 ଷ୍ଟାର ଲେଖିଦବ A0 A1 ସବୁ ଲେଖିଦବ କୋଏଫିସିଏଣ୍ଟ again equation ଟା ପାଇବ E star ଆମେ ଜାଣିଛେ psi star t h Hamiltonian psi di by minus into psi star psi t dt आ ଜାଗାରେ ଏଇ ସବୁ ଏତିକି ହେଇଗଲା ଏତିକି ଇକ୍ୱେସନ ଯାକେ ଆସିଗଲା ନେକ୍ସଟ ଆମେ ସବୁ ନର୍ମାଲାଇଜ ଫଙ୍କସନ ଦେଖିବା ଏତିକି 1 ଇଏ 1 ଇଏ ହଉଛି ତାପରେ ଆମେ କଣ ଇକ୍ୱେସନ କୁ ନର୍ମାଲାଇଜ ଇକ୍ୱେସନ ସହିତ ଇକ୍ୱାଲ କଲା ଇ ର ଭ୍ୟାଲୁ ଏ ଆର ଭ୍ୟାଲୁ ସବୁ କଣ ହବ ଆର ଭ୍ୟାଲୁ ସବୁ କଣ ହାମିଲଟୋନିଆନ ଅପରେଟର ହେଲେ ଇ ପଡିବ ଖାଲି ସାଇ ଜାଗାରେ ଇ ସାଇ a0 a1 ଷ୍ଟାର a1 କାରଣ ଇଏ ସବୁ ହାମିଲଟୋନିଆନ ଅପରେଟର ଇଏ ସବୁ ଆଇଜେନ ଫଙ୍କସନ ର ଆଇଜେନ ପରିଚୟ ତଳେ ତ ଆଉ ଏନର୍ଜି ଟର୍ମ ନାହିଁ ଖାଲି a0 a2 a1 ତାକୁ ସପୋଜ a0 b a0 star is equal to a0 so total হবে a0 square ହେଇଗଲା ଏସବୁ ହେଲା ପରେ କଣ କରିବୁ ଏଇ ଟର୍ମ ସବୁ ସେପାରେଟ କରିବେ this one is equal to divided by this one divided by this one divided so we'll get this separate equation so let consider this one as equal to b0 this one consider b1 this one comes to b so they will get this so obviously this expectation energy is greater than E0 कारण E0 it गुणा ହେଇଛି so E0 ଠାରୁ obviously extra so that's why we prove so this is the required condition of variation for will explain expectation value must be more than E0 okay next the expectation is determined by a method cannot be less than ground state the application of variation method. Let us take the application of variation theorem in order. In estimate the ground state system, compare actual value. Ground state for a simplest one dimensional, particularly one dimensional expression value. So we would recall the unit 3, we'll get the energy is h square by 8 ml square. हम 8 बार करते हैं देखो n square s square by 8 where n was 1 then E1 will be h square by 8 ml square ground state. It am state like one just ହଉଛି n1 ପାଇଁ h square by 8 ml square ତାକୁ 0. energy କହନ୍ତି ସେମିତି ଏନର୍ଜି ବଢି ବଢି ଚାଲେ ହେଲା ନା ନା ମନେ ପକେଇ ଦିଅ ଟିକେ ଓକେ ତ ଆମେ ସେୟା କହୁଛେ ଏନର୍ଜି ଟର୍ମ ହେଇଯାଇଥିଲା ତାକୁ ଆପ୍ରୋକ୍ସିମେସନ ମେଥଡ this is confined one dimensional library following trial function so देखो so ये normalize हो एक साइड ट्रायल दे देची साइड ट्रायल so आपको हमें केमती सॉल्व करें हमें सेम एक्सपेक्टेशन एनर्जी सेम इक्वेशन so this one will greater one so h square 2m d square by dx square h square 8 pi square m d square ताको एमती टर्म में पके and the value पके की will get extra derivation and करके हमें will get the value for derivation and value बाहर करेंगे so empty one dimensional box ready the value then approximation method will be applied for harmonic oscillator I mean last class harmonic oscillator देखते potential energy is equal to half kx square. That is from Hooke's law. Potential expression. So Hamiltonian operator for a system with Hamiltonian operator पढ़िबो a expression. Okay. h square 2m d square by dx square है plus half x. तो हमें Hamiltonian operator energy t plus v देखते ले t is the kinetic energy v is the potential energy. So Hamiltonian operator for a system. So after Applying the variation theorem to the model system of harmonic oscillator, we again take explain the same harmonic oscillator and harmonic oscillator. This is the Hamiltonian. हम जैसे size to side d square d square a square लागू से equation तो हार्मोनिक ऑसिलेटर approximation methods and calculate करके तारा नेक्स्ट हाइड्रोजन आटम रे केमती पडियो हम लास्ट क्लास रे हाइड्रोजन आटम रो बात करथले कोन साइज एटा होची तार कोन सॉल्यूशन है हाइड्रोजन आटम रो पोटेंशियल एनर्जी माइनस e स्क्वायर बाय बार टोटल हैमिल्टनियन ऑपरेटर बाय h स्क्वायर 8 pi स्क्वायर है डेल स्क्वायर लाप्लासियन ऑपरेटर माइनस e स्क्वायर बाय बाकू सेम अप्रोक्सीमेशन मेथड यही फार्मूला रे संबंध जहाँ जहाँ में बाहर करथले हैमिल्टनियन ऑपरेटर हाइड्रोजन स्पेक्ट्रा हो हार्मोनिक ऑसिलेटर हो रिजिड ऑपरेटर हो ସବୁ ଥରେ ଏଇ ଭେରିଏସନ ଆପ୍ରୋକ୍ସିମେସନ ମେଥଡ ଏଇ ଏନର୍ଜି ଏକ୍ସପେକ୍ଟେଡ ଏନର୍ଜି ଫର୍ମରେ ପକାଇଛି ଗୋଟେ କହିବି ସେମିତି କାଲକୁଲେସନ ନେଇକି ଆମେ ସବୁଆଡେ ଯାହା ଯାହା ପଢିଥିଲେ ହାଇଡ୍ରୋଜେନ ଆର୍ବିସନ ରିଜିଡ୍ ଅପରେଟର ଯୋଉଥିରେ ପଢିଥିଲେ then this is approximation method so we'll get the perturbation method what perturbation method we now take up the second approximation method that is perturbation method used to quantum mechanical theory. This method is used when a system can be viewed a slight modification on a slight modification of a system that has been solved and has been known to us. So perturbation method by using Schrodinger equation, H mu psi n E n psi. So here's the independent Hamiltonian operator for a system, but we are unable to solve it. H0 psi 0 E n 0 psi. Psi 0 is the known eigenfunctions and eigenvalues. So Hamiltonian operators interest can be expressed. So HB S0 plus H1 S2 S is a Hamiltonian operator combination interest. This has two parts. Hamiltonian represents system we know the solution will remaining the तो ये कौन Hamiltonian operator को combination of Hamiltonian operator by Potter-Gaussian equation. So listen, we have a for one dimensional narrow harmonic measure h square 20 square d half is Hamiltonian operator. For non-harmonic oscillator, this term will be added to it. Harmonic oscillator will be this term. So this is the H. So now we'll prove the Potter-Gaussian theory here. So listen, H psi n is equal to E n psi n. So H H0, H1, H2. So Hamiltonian operator is becoming. For simple harmonic oscillator, this will be Hn0, En0 psi. So empty taku ସବୁ କଣ will multiply. So this is the multiply with the lambda wavelength. Sin n0 lambda yn1 lambda square n. So this is the equation, a mathematical equation for perturbation theory. One first one, then lambda square, lambda cube like this. So this will be the equation in perturbation theory. So yn seମିତି eigen function wave function ହେଲା so energy भी seମିତି lambda square like this. The successive terms in this expression are lesser than lesser. Psi h0 lambda n like this. So get this. ଆମେ ତାକୁ ଯେମିତି କରିଥିଲେ ତାକୁ same, କିନ୍ତୁ ସେଠି combination A1 plus A2 plus lambda Q like this. Right here, equation like H0 sin 0 minus sin 0 sin 0 sin 0 ଏମିତି ସବୁ କଣ ଏ solve କରିକି କଣ ମିଳିଲା ଆମର H0. So here this one is equal to this one. Multiply this equation with lambda n and psi n h n. तो जब करेगी लास्ट को एमपी प्रूव करियो दिस इज ऑर्थोगोनल फंक्शन ऑफ माइक्रोवेव जो वाली 0 और 1 Hamiltonian operator. So what are the basic requirement for perturbation method used for? What is the basis of the perturbation theory ପାଇଁ କଣ basic requirement? ଆମେ କଣ perturbation theory ଦରକାର zeroth order of wave function with the lambda will be the coordinate coefficient in all the cases. Then application of perturbation theory for particular. ସେଠି ଯେମିତି approximation use ହେଲା ସେମିତି ଏଠି perturbation theory use ହେବ h square by 8 ml square. तो ଆମେ ଜାଣିଛେ वो particle in box है confined from 0 to L. So this is particle in box in one confined surface. ସେମିତି ଆକୁ ବି perturbation theory will be applied in perturbation theory. Sorry, particle in box energy Hamilton operator h square by 2x square n square by h square by 8 ml square will apply in perturbation equation. Perturbation equation, so the approximation method. Same formula usable using mathematical term. Similarly, same perturbation theory will be applied to harmonic oscillator. So this is uh, harmonic oscillator. Harmonic oscillator. This is Hamiltonian operator h square by 2 ds half kx square. So ये apply हुआ ये क्या E0 apply कि this will be the so ଆମେ ତିନିଟା ଚାରିଟା ଜିନିଷ ପଢିଲେ ଗୋଟେ ହଉଛି particle in one box harmonic oscillator rigid rotator ରେ ଖାଲି angular momentum ଏମିତି ହେଲା hydrogen spectrum ତା ଦେହରେ approximation method ପକେଇବ perturbation method ବି ପକେଇବ ଦେଖ Hermitian operator consider तो ଏଠି Hermitian operator ପକା ହବ ପକେଇକି result so comparison of various and perturbation methods have been learned. So this is all about which approximation method is studied and so unit 9 रे हमें पढ़िले कौन full recap this is summary so हमें दीटा approximation method पढ़िले गोटे होची variation method variation theorem आउ होची गोटे perturbation theorem so आमे variation method रे derivation of variation theorem पढ़ले that is application of various method on one dimensional box harmonic oscillator and hydrogen atom. Similarly perturbation method पढ़ले derivation of perturbation theorem पढ़िले and application of perturbation theorem on one dimensional box harmonic oscillator पढ़िले. All are mathematical expressions so you have to study no doubt. So ଆମେ ଆଉ ଥରେ ଟିକେ ଦେଖିଦବା ତାକୁ variation method ଆମେ just this is the variation method so variation method this is the equation of variation method आर derivation माने तार normalize करके orthogonality करके we get the variation method रो कौन application पढ़िले तापर ताकू prove करिया variation method by using this variation method use करके would be at this function prove करिया तार मेथड को कौन प्रूफ कले दिस इज द प्रूफ ऑफ वेरिएशन मेथड चला अप्लाई फर्स्ट वेरिएशन मेथड देखिबा ताको प्रूफ करिबा देन दैट विल बी अप्लाइड इन डिफरेंट केस फर्स्ट अप्लाई करे पार्टिकुलर इन वन डायमेंशनल बॉक्स रे तापर हमें कहउतले हार्मोनिक ऑसिलेटर रे तापर हम हार्मोनिक ऑसिलेटर अप्लाई कले तापर हमें अप्लाई करिबा ताको हाइड्रोजन स्पेक्ट्रम माने गोटे थियोरम पढ़ले तार प्रूफ पढ़िया तार एप्लीकेशन तीन जगह रे करिया गोटे होची पार्टिकुलर इन वन बॉक्स हार्मिस हैमिल्टोनियन ऑपरेटर हाइड्रोजन एटम सो ये कोड अप्रोक्सीमेशन मेथड को अप्लाई कर तापर हमें पढ़िया परटर्बेशन थ्योरम को परटर्बेशन मेथड concept system scoring algorithm given by perturbation method. So this is the scoring in perturbation. This is the system interested in perturbation method. से perturbation method को prove करिए proof of perturbation method हम prove कराला भाई हम इंटरेस्ट सब पकेगी will get perturbation सारे आधा का लैम्बडा गुना लैम्बडा this is the proof of perturbation method. Then that will be applied in perturbation method will apply in one dimensional box, particularly one dimensional box. Perturbation theory usually that will be applied in harmonic oscillator, usually harmonic oscillator रे then that will applied in hydrogen perturbation theory. So I mean till now we have started unit 10 like last class रे हमें खाली unit 10 ର revision କିଛି question answer discussion करता हुआ so in this chapter we have unit we have studied कौन पढ़ ले हमें variation method कौन how it will derive and how it can be derived from this derivation of this theorem and application of this perturbation theory in one dimensional box also harmonic. Okay. So next class में हमें next class how to division करी we'll go to the 10th class. So हमें याको पढ़ ले आज ही हमको पढ़ ले हमें हाइड्रोजन स्पेक्ट्रम के पढ़ते ले we'll see हाइड्रोजन आटम रा आज पढ़ी छे हमें हाइड्रोजन आटम रा पढ़ ले most atomic model when the hydrogen quantization of energy can be calculate कर ले के देखी दो बार रिवीजन कर दो आज ही देखो तो स्लाइड के देखा just a revision summary of today's lecture and the most relevant equation how calculate and energy state of hydrogen atom what are the different energy state first energy state is equal to minus 2.18 into 10 to the minus 18 joule z square by n square. So in which case energy will absorb, in which case energy will emit. We have discussed here. Most model revisited, most model कौन कहला? Electrons are revolving around the nucleus in a certain path. That path is known as orbit, and that the energy of orbit can be quantized. we can calculate the energy of that path. So that energy is this one. So hydrogen can absorb from one energy state to another energy state through only certain. So that will add applied in Schrödinger equation. समस्त Schrödinger equation को ढूंढना है. Okay. तो Schrödinger equation of पकाला H psi equal to E psi. Psi is the wave function of atomic orbital. A mathematical description of motion of electrons matter. H is Hamiltonian operator. E is high energy of atom. So that will expressed in this equation. So from the Hamiltonian operator, we'll get four quantum number, principal quantum number, azimuthal quantum number, and uh, magnetic quantum number and spin quantum number. So all the quantum number, principal quantum number हमें energy state by energy value of nth orbital and magnetic as ये हो energy state देखो. Next, quantum mechanics. AL value, angular momentum shape of orbital by one ASP, तो n ର value n ଉପରେ l ର value n ଉପରେ depend କରେ m ର value ବି n ଉପରେ କହିଲେ ଆମେ ତ ଆଜି ଆମେ ୟାକୁ ପଢିଲେ just a minute. Next time ଆଜି କଣ ପଢିଲେ ଅଛି 109 ତୁମେ ଆମେ ଯିବା ଦେଖିବା ଆମର ବ୍ଲକ୍ 1 ବ୍ଲକ୍ 2 କୁ ଦେଖ ବ୍ଲକ୍ 2 just a minute. So block 2 रे हमें हार्मोनिक ऑसिलेटर पढ़देले हार्मोनिक ऑसिलेटर रिजिड रोटेटर पढ़ଥିଲେ हाइड्रोजन एटम 1 2 मींस अदर एंगुलर मोमेंटम सब गला हाइड्रोजन 1 2 रे और वन डायमेंशनल वर्क हमें 9th पढ़ले आउट 10th आज 10th पढ़िया लास्ट वन तो हमें पूरा सब पढ़ देते जस्ट recap for you harmonic oscillator rigid rotator खाली पढ़ते यूनिट 1 ଏବେ block 1 fundamentals introduction of quantum chemistry introduction to wave mechanics party तो last class next class हमें सब को revision कर दो just quantum chemistry wave mechanics postulate कर दवा one dimensional Gaussian derivation important three dimensional ର ऐसा पढ़ जाइए नौ पढ़ले 10th unit last unit ଅଛି तमरो तारे हम सब कौन पढ़ले classical black body radiation, photoelectric effect, heat capacity, first class का सब पढ़ते थे तो 10th रे कौन सी थी देखिए so 10th will join 10th this so multi electron atoms wow that is a hydrogen like atom helium atom or Schrodinger equation can solve approximate ground state energy of helium atom or faster helium multi electron atom रे केमती सब काम होची helium ର ଏ ସବୁ କାରଣ next class ରେ ପଢିବା helium atom ରେ କେମତି Schrodinger equation काम କରୁଛି helium atom helium ରେ କଣ ଦିଟା ଇଲେକ୍ଟ୍ରନ multi electron system next class ରେ ଆକୁ ପଢିବା helium କଣ ଅଛି ଦେଖିବା ସବୁଆଡେ mathematics approximate state energy fast order perturbation theory पढ़िया variation method for helium next class में example दवा perturbation theory electron and one okay हम last class में टिके revision perturbation theory कर दवा particular one dimensional box and the portfolio just a recap आर कौन derivation करथले potential Schrodinger equation and have a term play potential to zero करी yes I zero जो बाद में फाइनल क्वेश्चन हमारे नॉट एक्स स्क्वायर बाय 8 स्क्वायर ये वाला नुकसान है और nx and y and z can be equal can be different depending upon the so energy E1111 nx1 ny1 and z1 3s square by 8 so we get a degenerate alpha non-degenerate degenerate triple degenerate the पाइथन तो सेम ये तीन तारा एनर्जी हम सेम ये तीन तारा एनर्जी तो ये सब सेम एनर्जी सब ट्रिपल डिजेनरेट ये भी से ट्रिपल है ये नॉन डिजेनरेट है आपको वाला पर नॉन डिजेनरेट इस वेरी इंपॉर्टेंट particular one now so you need to particularly to different postulates so postulate y function or state function is an important psi कौन पढ़ते psi square कौन पढ़ते तापर different time dependent wave function postulate 2 postulate 3 एरा सब operators कौन different Hermitian operator Hamiltonian operator so these have studied so this is the function explain first so ये equation are use कर eigenvalue of expectation value so हमें कौन expectation explain postulate करे then we average value or एटा हमें यूज कर लेने हैं कोथरे approximation method रे यूज कर ले expectation और average value so a derivation of time dependent Schrodinger wave equation तापर हमें एटी हाइड्रोजन एटम विषय पढ़ते मोलेकुलर एटी पढ़ते हमें कौन हार्मोनिक ऑसिलेटर कौन फर्स्ट क्लास रे हार्मोनिक ऑसिलेटर कौन हमें क्वेश्चन बात करते रिजिड रोटेटर maximum in some rigid rotator or their angular momentum. This is very important question. How calculate the angular momentum here. So value of angular momentum also. How damn put hydrogen spectra, hydrogen atom quantum mechanical treatment. Hydrogen atom. Just to recap for it. Quantum hydrogen atom. So application of Schrodinger equation in hydrogen atom. Potential value है so a time independent yes sorry independent Schrodinger equation for hydrogen atom. So in coordinate Cartesian coordinate application of Schrodinger equation for r theta phi ର solution ଦେଖିଦେଲେ solution of Schrodinger equation ଆମେ ଦେଖିଲେ these are different terms. So आधरे radial equation ଦେଖିଲେ angular equation ଦେଖିଲେ ଆମେ solution of radial equation ଦେଖିଲେ ଆଧରେ quantum number ଆମେ ଦେଖିଲେ a ର value m ର value ଦେଖିଲେ a ର value କଣ ହେଲେ ଏଟା ପରିବ a ର value କଣ ହେଲେ m ର value ହଉଛି minus l ରୁ plus l through 0 ସବୁବେଳେ very quantum numbers. Hydrogen at a radial wave function for different 1s ପାଇଁ କଣ 2s ପାଇଁ କଣ 3s ପାଇଁ କଣ ସବୁର ବାହାରୁଛି. Angular and azimuthal equation different spherical equation solution of angular and azimuthal. So quantum numbers n l m principal quantum number azimuthal and magnetic quantum number. What is the restriction of quantum number? N value will be greater than 0 and A value always will be less than n and M value less than equal to n. So n value L value depends upon n, M value depends upon n. So by using principal quantum number, you can calculate the energy of nth orbital of Bohr's atomic model. A level gives angular momentum as well as shape of a orbital. So A level can the angular momentum Al into L plus 1 root over. L into L plus 1 root over. L ହଉଛି angular momentum, small l ହଉଛି କଣ azimuthal momentum. Suppose p orbital ପଚାରିଥିବ L value 0, 0 ହବ angular momentum. P orbital value L 1, 1 into 1 plus 1, 2, 2 ର root over ହବ. ସେମିତି L value 2 ହବ. And d orbital ପକେଇବ 2 into 2 plus 1, 2 plus 1 3 into 2 into 6 root over 6 ହବ. So L 0 ପାଇଁ S, 1 ପାଇଁ P, 2 ପାଇଁ so certain energy level it degenerate with respect to L when energy is independent of L. So magnetic quantum number. So minus L plus ये देखा 2 देगी plus 2 ରୁ minus 2 plus 2 plus 1 0 minus 1 minus 2. So ये याद होगा. The magnetic quantum number can be L value. Okay. So these are the different terms. So energy levels, different energy levels पढ़ते अब selection rule पढ़ते delta L is equal to plus or minus 1. Delta N anything. Delta L plus minus 1. और delta ML is 0 plus or minus. So electron absorbing or emitting photons to change states when delta L plus or minus 1 माने 1 ରୁ 2 କୁ ଯାଇପାରିବ 2 ରୁ 1 or 2 ରୁ 3 କୁ ଯାଇପାରିବ 3 ରୁ 2 କୁ ଆସିପାରିବ. But cannot be 1 ରୁ plus 1 ରୁ minus 1 ହେଇପାରିବନି minus 2 ରୁ plus 2 ହେଇପାରିବନି କି 0 ରୁ 1 ହେଇପାରିବ 0 ରୁ 2 ହେଇପାରିବ କି 2 ରୁ 0 ହେଇପାରିବ. Probability distribution of radial wave function हम देखते. So this is probability distribution of radial wave function at states of hydrogen atom. So this is the quantum number frequent or 2px ये कहते हैं 3px z 3pz 3dz square. एमती होची ऑर्बिटल शेप ऑफ ऑर्बिटल. So till now we have studied different approximation method, contribution methods. So ଆମେ କଣ ଆଉ यूनिट 10 ଟା ଖାଲି बाकी ଅଛି. So we'll study the unit 2. Yeah. In next class, last class, unit 10 ରେ ଆମେ କଣ ପଢିଦବା ତାର different multi-electron systems पढ़िया. We'll revise and we'll give some questions there. Okay. प्राय समझते लेते हैं. फॉर्म का दवा क्लास है विश्वप्रिया.
Yes,
Am
sir.
I audible?
Yes, sir.
सुबह तो
Again, sir.
क्लास साइड रखिदवा रखिया.
Yes, sir.
नेक्स्ट क्लास रे हमें यूनिट 10 लास्ट यूनिट टा पढ़िया.